Okay, hello everyone, you're all welcome to this video. This is a continuation of 2011 past question solution. So here we have number 38. It says electrical energy stored in a capacitor is given by the expression. The answer is C. Okay, electrical energy stored can be half CV squared, it can be half Q squared over C, and it can also be half QV. They are all related, so one of them is. Now the next one says a 120 ohms resistor is connected across an AC having a maximum voltage of 283 volts. Calculate the RMS value of the current in the circuit. Okay, now first off, we are given we know that voltage is supposed to be current times resistance. So the resistance in this case is going to be equal to the current in this case is going to be equal to the voltage divided by the resistor, and that is 283 divided by 120. Okay, so I can do divide that quickly. 283 divide 120. Okay, that is giving me 2.358. So I'm going to write here 2.358, which is approximately 2.4. Now, but if you notice, this is maximum voltage, and maximum voltage can only be used to get maximum current. Okay, because we are asked to find the RMS value of the current. So the maximum current is 2.353. Now the RMS value is always equal to 0.707 times the maximum current, or you can say the maximum current divided by root 2, whichever. So now we are going to, this means 0.707 multiplied by I naught is 2.358. So I can quickly check that. 0.707 0.707 multiplied by 2.358. Okay, so that is giving me 1.667. So the answer is 1.667 amperes, approximately 1.7 to 1 decimal place. So the answer is C. Okay, quite easy. Now the next one says that use the circuit above, determine the value of R in the null deflection. Now this is what we call a Wheatstone bridge, and once there is a null deflection, what it simply means is R1 over R2 will be equal to R3 over R4. That's the formula. So in this case now, my R1, R2 can be 10 and 12, right? Okay, so I can say that 10 divided by 12 is equal to, then here is 7.5 divided by R. Yeah, so this is my R1, R2, then R3, R4. Quite interesting, right? Okay, now this will now be, that means your R is going to be 12 times 7.5 divided by 10. I think this is 6, this is 5, this is 2.5, this is 12 plus. Okay, that's 15. So the answer is meant to be 15 ohms. I'm not seeing any 15 ohms. I hope I'm not making a mistake. Okay, let me use a calculator. 12 times 7.5 then divided by 10, I guess. Okay, so the answer is 9. Okay, so I made a mistake. So 9 ohms is the answer. Good. Now number 41 says, which of the following method is most effective method in making a magnet? That's definitely the electrical method is the most effective method in making a magnet. Okay. The next one says, which of the following factors does not increase the strength of an induced EMF in a solenoid? Okay, we have in a solenoid, the induced EMF in a solenoid is we can use BAN omega. That's in a loop, right? Which is approximately solenoid. So number of turns, speed, polarity of the magnet facing, no, polarity has nothing to do with the strength of the induced EMF. Okay, cross-sectional area, yes. Speed, yes. And number of turns, yes. So those are what we instead of saying polarity of the magnet, we would have said intensity or the strength of the magnet. Okay, so the next one says, two identical parallel conductors close to each other carry equal currents in the same direction. Okay, which of the following statements is not correct? Okay, each of the conductor will experience a force. Of course, this is correct. Each of the conductors can move. Well, yes, because force always causes objects to move. See, the magnitude of the forces on the conductors will be equal. Well, since the two are identical and they carry equal current, then the magnitude of the forces are equal. Then this one says the two conductors will repel each other. That's not true. If they are carrying charges and moving in the same direction, the kind of force between them will be an attractive force. But if the direction of the current is moving in opposite direction, then the force is going to be a repulsive force. They are going to repel each other. Okay, very important. Now number 44 says, in the wiring of houses, the switch is connected to the the answer is the earth and the neutral wires bridged together. Okay, so it has to be connected to the earth, right, and the neutral wires, all of them. Now the next one says, number 45, a circuit consisting of a resistor R, an inductor L, and a capacitor C in series is connected to an alternating source at resonance. Okay, at resonance the current is maximum, impedance is maximum, current is least, frequency is maximum. Well. First of all, is the answer is A, the current is maximum. Now there are different things that we should know about resonance. First of all, at resonance, XL is equal to XC. Okay, XL is equal to SC, and that's the reason why the impedance is least at that point. Okay, but if the impedance is least, since voltage is equal to impedance over current, and impedance is least, it means that current times impedance. So current is maximum. Okay, current will be maximum in this case, and these are some of the things that you should know about this. And again, you should know that the impedance is equal to R, equal to the resistance. Very important. Now number 46, which of the following radiations is not part of the electromagnetic spectrum? Of course, alpha particle is not. So alpha particle is the answer. Okay, now the next one says, let me take this. The next one says, which of the following constituents of an atom enables matter to conduct electricity? Now the constant of an atom that enables matter to conduct electricity, that is very common, that's electrons, right? Now the next question, number 48, says, the diagram above illustrates some energy levels in an atom of hydrogen. Which of the transition I to IV will produce an absorption spectral line in the hydrogen emission spectrum? Okay, which of the transition I to V will produce absorption spectral line in the hydrogen emission spectrum? Okay, will produce an absorption spectral line in the hydrogen emission spectrum. Okay, I think I would have to skip this because the question isn't very clear, because absorption simply means you are going from a ground state to an excited state. That's what absorption is. You absorb energy to move. So I'm not seeing anyone here, so I'm going to leave that. Now number 49 says radium disintegrates as illustrated in the equation below. Identify particles X and Y. Well, I think this is easy. Particle X is definitely alpha particle. Particle Y is neutron. This is the neutron, has a mass number of 1, atomic number of 0. So the answer is alpha particle and neutron. C as the answer. Then number 5 says it is not very possible to determine exactly and simultaneously both the position and momentum of a particle. This statement is called the Heisenberg uncertainty principle. Very easy. Okay, so that is it for the objective. The next we're going to be looking at will be the theory. Okay, thank you very much. See you in my next video.